Hey GCSE physicists, welcome to my video on power equations. I'm going to be going over when we'd use all the different equations for power and for energy transferred today. Don't forget that you can also have a look at this content on my resources on the My EdSpace website, and if you have a look at the link in the bio below, you could join my live lessons. So let's get straight into this. Now, power is the energy transferred every second. So if I say that an object is more powerful, I mean that it transfers more energy every second. You'll notice, however, though, there are two equations for how we can calculate the power of a device that's got current running through it, so an electrical device. And how do you know which one to use? I'm going to help you with that. So let's start by having a look at our first equation. So P always stands for power, and we measure power in the unit watts. I stands for current, and we measure current in the unit amps. V stands for potential difference, and we measure that in the unit volts. Now, if we look at the equation below, we've got P for power again. We've got I for current again, but note that the current is squared. However, this time we've got resistance. So we'd use this equation if in the question we're given the quantities power, current, or potential difference. We'd use this one below if we're looking for power, current, or resistance. Remember that resistance is measured in ohms. Now, energy and power are related. So let's go and have a look at our equations to calculate energy transferred. So, this is the equation you might be familiar with already, because this doesn't just apply to an electrical component. Any device, if we know the power, this can be a mechanical device as well, so something that uses forces, for example, to like lift an object. Any device, we can calculate the energy if we know the power and we know how long it is on for. So here the E stands for energy transferred, and that's in joules. P again stands for power, which we measure in watts, and T is the time taken, which we measure in seconds. Now, if we've got an electronic device, we can measure the amount of energy transferred if we know how much charge has been transferred and we know the potential difference of the device. So if we're given energy, power, or time, we'd use this equation. If we're given energy, charge, or potential difference, we'd use this equation. So E again here is for energy transferred, which is measured in joules. Q is charge, which we measure in coulombs. And V is potential difference, which we measure in volts. Now, if you want to see lots of worked examples of these equations being used, don't forget to check out the My Resources page for power equations on the My EdSpace website. There's loads of worked examples and practice questions there for you to have a go at, and some videos for me to give you a hand. Don't forget to subscribe to my channel if you enjoyed this video, and while you're down there you can check out the link to have a look at joining my live lessons. I hope to see you soon. Bye!